In this part of the video, we're gonna review solving systems of inequalities. And for this, we're on page 43 in the packet, and we're working on starting with problem number 10 here. So anytime you have a system of inequalities, or just a linear inequality in two variables, now we've done things like x is greater than 3 for quite a while. We could even think of this in one direction, where you have 3 on a number line, in the open circles, and we're shading to the right and all that fun stuff. But we're graphing in two dimensions now, and anytime you have x equals, it's a vertical line going over here at 3, and in this case it's going to be a vertical dash line because our inequality doesn't have that equality part. So anytime that there's an equal sign on there, you're going to graph that part of the line like a line. But here, what this represents is all the numbers, all the x values that are bigger than 3. So what x values are bigger than 3? So like 4 is greater than 3. 3 is not. These are all the points right here, like this is 3 comma 2. That would be this point right here. But that doesn't work, because if x is 3, this is not bigger. So things that will work are things like 5, 2, or whatever this is. This is 3, 4, 5, 6, 7. Is it 7 or 8? 4, 5, 6, 7. So 7 comma 2. That would work because x7 is greater than 3. So everywhere in this region right here, you're going to have x values that are bigger than 3. Because this is the x-axis, and here's where x is 3, is this little line right here. So anything that's in this shaded region here would be a solution. So there's an infinite number of solutions, and so 7 comma 2 would be a particular solution. Means they're not solutions would be like 0, 0 is not a solution. Now a couple ways of remembering this. One thing you could think of is this is a greater than symbol because it doesn't make an L, so this would be a less than symbol because it makes an L on the page. This is not an L, it's going backwards. So it's a greater than symbol, and the bigger x's, because this is like x, this is the x-axis, the bigger x's are on the right. So I could draw little arrows off of this graph going to the right. Now one thing you have to realize is those arrows just tell you which side to shade. You still have to shade over here on the right hand side. Alright, let's see what happens when there's an x and a y. So in this case, you're going to draw the line just like normal. And it's an mx plus b, so we go down 3. So down here, and then the slope is 2, so it goes up 2 over 1. And we plot it, and it's a dashed line because there's no equal to. So if there was an equal to sign, you draw it as a solid line, but this is a dashed line. And the dots themselves are probably enough. I don't necessarily have to make more dots. And this is a y is less than, so the smaller y's are down. So put your little arrows off the graph going down, and we're shading on that side. Now another thing you can try to do is just to pick a point, something like 0, 0, something easy. Is 0 going to be less than 2 times 0 minus 3? Is 0 less than negative 3? Well, I hope the answer is no, which means you do not shade over on the side that's got the 0, 0. You shade on the side that doesn't have the 0, 0, so over here. So solution, let's go with 100 comma 0, because that would definitely work being somewhere out there. Alright, our third example, we've got lots of stuff going on. The main thing that's going on is you're not in slope-intercept form. So we have to move the 2x over. So we're going to add the 2x over the other side. And then the other thing we have to be careful about is we have to divide by negative 3. And there's not a lot of room here, I know. So here I'm going to import this right over here. So this negative 3y divided by negative 3 becomes a positive y. Whenever you divide by a negative, you have to flip this inequality. So instead of a less than symbol, it becomes a greater than symbol. And I'm also going to do the x's first. So I get a negative 2/3 x. And then my 6 divided by negative 3 would be negative 2. So we start down here at negative 2. And this goes down 2 over 1, 2, 3. Down 2 over 1, 2, 3. Or it goes up 2, left 3. Up 2, left 3. So this is a solid line. I know it's always tricky to draw on this thing, so let's do my best, try to get those dots. Yeah, that wasn't so bad. And now that we have flipped the inequality, it is a greater than symbol, and the bigger y's are. So we're going to shade everything up here. And some people do a great job shading. I don't particularly tend to. And 0, 0 would definitely be a solution. So that's what happens when it's just 1. So that's what we call in target 22 right now. So what happens when there's more than 1? Okay, so that's our target 23, and that's a system of inequalities. Now in these problems, they're pretty much exactly the same thing as before. And the first thing you really want to do is you want to clean these up and move over your variables if you need to. Negative y is greater than x minus 3. Divide by negative 1, get the y all by itself, and so y will be less than or equal to negative x plus 3. So this graph starts up 3. And then it goes down 1 over 1. And I happen to graph the more complicated problem first, but it doesn't matter which line you draw. Just went with the one that had the most work to it. And this is a solid line. I'm going to be lazy with the other side there. Let's try to actually make it look about right. Oh, that was not so good. All right, let me be a little bit more precise. Draw my dots, because that makes it just a little easier to connect them. We'll see how they're doing there. Yeah, not too bad. And then this is a less than symbol. Now when there's more than one going on, you need to be careful. So the smaller y's are down. Now I don't particularly want to shade all of this right now because I have more than one thing going on at the same time. I also have like x has to be greater than negative 2, or greater than or equal to 2. So I go over to 2, and it's a solid line here. And it's a greater than symbol, so the greater x's are to the right. X's go right and left, whereas y's go up and down. So now I'm looking at where all of these things overlap. And so there's 4 regions it could possibly be in. In the first region, I do have an arrow here, but I don't have one for the red line. In the middle here, in number 2, I have no arrows, so I'm blanking out here. In the third region, I have the red arrows, but I don't have any black arrows. But the fourth region, both arrows are pointing there. So that would be my solution. So you should pause this now. And first off, go through and finish the problem if you have to finish it. But I want you to try number 14. And then when you unpause it, I'm going to work it through really fast. So pause it, try 14. Alright, so hopefully you tried it. If you didn't, still supposed to pause it. Alright, so this first one goes up 1, goes down 2 over 3, down 2 over 3. And it goes the other way, up 2 over 3. And it should be a solid line. And it's a greater than symbol, so the arrows are going up. The other one's down 2. And it goes up 1 over 2. And that should be a dashed line. And those arrows are less than arrows, so we should be shading over there. Alright, I'm not going to do 15 and 16 with you guys because I want you to try them. And if you need help with them, you should be checking on the answer key that's on Schoology as well. So let's try 16 version 2 here. So we're numbering here. Write a system of inequalities for the given the following graph. So again, you should pause this and try it. And then if you have no clue, then I guess stop pausing it and keep going. So let's actually answer the second question first. Is negative 2, 3 a solution? So if I go down to negative 2, up 1, 2, 3 a solution to the system. Ooh, that's a tricky one because it's on the edge. Now here's the thing. The solid lines are solutions. That's the whole idea of drawing them. Solid, meaning they are part of the solution. However, the dashed line, these are numbers that don't quite work. 2 is not less than, 2 is less than or equal to 2. But 2 is not less than 2. This is not a true statement. So anytime that you don't have the equal to sign, we put a dashed line, which means any number on that line, on that edge between being bigger or smaller, all those are going to get thrown out. So at this point here, as on both the solid and the dash, now the truth of the matter is we're doing the intersection of these two sets, which is the AND statement on both of them. So it has to work on both equations. So it works on the solid line, but it doesn't work on this dashed line. So the answer is no, it does not. So it has to work everywhere. It can't just work in one of them. It has to work in both. Alright, let's take a look at our equation. So first, let's do a dashed line first. So y is, in this case, going to be less than, because the arrows for the dashed line, actually arrows for both of them are going down. So they're both going to be y is less than. But on the solid line, it'll be less than or equal to. So for our dashed line, it's here. We have to come up with the slope. So it goes down 1 over 2. So negative 1/2 x plus my y-intercept of 2. And then the other one, I need my slope, so it doesn't really matter where I go, but I got to go from one good point to another good point. So let me erase these little dots to make sure we get a good point. So here's a good point, right here, our intersection point, but then when's the next good point? Right here. So it goes down 1, 2, 3, 4, 5 over 2. So negative 5 over 2x minus 2, because the y-intercept is negative 2.